So good day to everyone. Thank you for participating in organizing the conference. My name is Denis Gordeev. I work at the Russian Presidential Academy of National Economy and Public Administration in the Data Analysis Laboratory. And I'd like to present our work, Relation Extraction Dataset for the Russian Language. So, as it can be seen from the title, we have constructed a dataset. In this paper, we describe it, and in this presentation, I will tell why we have created it, what are our results, and how we created the dataset. Hereby, you can see the link where you can find the dataset. So, first of all, why did we decide to do it? We wanted, first of all, there were no relation extraction datasets besides factory val, and the number of texts there was quite small. We also tried to use English cross-lingual transfer with Takrit, but it didn't work. We tried translating it. We tried the same method as Davletov with multilingual BERT models, but still we couldn't make it work. Maybe someone will succeed in it. So, and that's why we decided to create this general relation extraction dataset. As far as we know, there are no general relation extraction datasets for the Russian, except the ones that are automatically created, parsing the Wikipedia. So we took some random lenta.ru articles that are hosted on GitHub. Thanks for this, it makes it very convenient. Okay, we annotated a little bit more than 500 texts, and we are going to increase this number. For each text, we had 2 annotators. There were 5 annotators in total. All in all, our dataset is smaller than Gordeev, about which you know, but it is general relation. It contains general semantic relations, and Gordeev might be problematic to use besides the domain that it was created for. However, Gordeev may be better than our dataset for benchmarking. We stuck to Ontonode's 5 guidelines. We use Brett for annotation. And here you can see their distribution of named entities. So, as you can see, we have a very wide tail here, which is very common for real datasets. The most popular entities are organizations, countries, and people, in which we were the most interested in. Okay, we also added some new entity types besides the ones from Ontonodes. As you can see, they're mostly hierarchical. So if you are not interested in these entity types, you might just use GPE or other general entity type. Okay, as you can see, as you have heard, we were inspired by Takrit, and we used pretty much the same relation types there in our dataset. We have just mostly relations between people and organizations and between groups of people. So someone works as someone, someone is a parent of somebody, some organization bought another organization, some organization is headquartered in some city or country. Okay, so we also have here white-tailed distribution. As here we can see annotation example. As you can see, we also annotated abbreviations. As you can see here, the example of Ukraine and the High Court, Высший хозяйственный суд Украины, we labeled it as two separate entities, and we did it in all similar examples. It might be not the best idea, but we decided that it helps us to see the hierarchical relations between these types of entities. But yeah, Высший хозяйственный суд Украины, it's just one entity. It might be considered so, but in our case it's not. Okay, some entities might have no relations. As for our kappa scores, we have 0.77 for named entities and 0.79 for relations, but the relations number is skewed due to named entities disagreements. So if we have so for example, if someone, as in the previous page, labeled Высший хозяйственный суд Украины as one entity, we'll have a disagreement on ownership. We'll have a disagreement on the ownership relation. So it's not very high, but it's better than nothing. As you can see here, we might have various mistakes, various disagreements. So for example, entities might contain different number of words, summit or газовый summit. Some entities might have been labeled with different entity types, so facility or organization. It's a very difficult question. Because in some cases organization in our work, organization is something that buys someone or buys from someone, and facility is like a house, like a building. It doesn't perform any economic activity. Okay. So we also trained some models for named entity recognition and relation extraction. We used only transformer BERT-based models. We used RuBERT and BERT weights, and as you can see here, BERT was better in our case, but the difference is negligible and it's not, I would say, statistically significant, really. With different hyperparameter tuning and different in another initialization scheme, RuBERT might have been better. So that is. Thank you for your attention. Please write on our GitHub. We'll continue developing the model. If you have any questions, please ask.